Fuel economy estimates for automobiles has a mean of 27.8 miles per gallon, standard deviation of 5.2 miles per gallon. That's for highway. Okay, so we're assuming that the normal model can be applied. And so this rule they're talking about, the empirical rule, means that we should expect 68% of those cars to be between, let's subtract the standard deviation, to be between 22.6 miles per gallon and 33 miles per gallon. I subtracted the standard deviation for what we call the lower bound, and I added a standard deviation for what we call the upper bound. And I already forgot what the lower bound was, but okay, 22.6. So in my graph, 68% of the numbers, if I can zoom in, I gotta click this. 68% of the numbers should have 22.6 as the lower bound, which this one does, so that's possible. That's our correct graph. This one has 25.2 as the lower bound, so that's not the correct calculation based on the empirical rule. You just subtract the standard deviation. It should be centered at the mean of 27.8, and looks like both of these have 22.6 for the lower bound, but it looks like the upper bound for 68% is different. So let's find out. Let me recalculate that again. 27.8. If I add a standard deviation to it, we should be 33 for the upper edge of the 68%. Right? So if you're within one standard deviation of the mean, 68% of your number should be there if it's normally distributed, right? And if you're 2 standard deviations away, then you've captured 95% of the data because you've cast a wider net. And we just checked the 68%. There's only one that matches both the lower and upper bound. This one's at 38.2, which is not correct. That's part A. I'll continue. In what interval would you expect the central 99.7% of automobiles to be found? Okay, so we need to take away 3 standard deviations for the lower bound and add 3 standard deviations for the upper bound. So 27.8, I'm going to take away 1 standard deviation, 2 standard deviations, 3 standard deviations. We expect 12.2 to be the lower bound. The upper bound, 42.6. And if you're wondering why did I do 3, where did I get the number 3 from? It's because, look, this is 1 standard deviation away, 2 standard deviations away. So 99.7 means 3 standard deviations away. Oops. I must have miscalculated something. Oh, and accepted this one, so maybe I typed something in wrong. Oh, I didn't type 27.8. Okay, that plus 5.2 plus 5.2 plus 5.2, so 43.4. About what percent of automobiles should get more than 33 miles per gallon? So I think 33 was the upper bound on 68%, right? We add 1 standard deviation, that's 33. Okay, so what should get more than 33 miles per gallon? Let's draw this out real quick. Here's my terrible normal distribution. 33 is right here. And then I forgot what the lower bound was, but this should be 68% of the data between these two, right? Because if you subtract a standard deviation, if you add a standard deviation, we already did that in part A, that's this set of data. Now, we can extrapolate from this, though. At 68%, then take away 68% from 100, you got 32% to cut up evenly between both tails. That means there's 16% over here, and there's another 16% over here, right? And I think the question was more than 33%, so we just found out by drawing the normal distribution that 16% are more than 33 miles per gallon. Now, between 33 and 38.2, so 5.2 is my standard deviation. So I think that's just another one, 33 plus 5.2, so that's 38.2. Getting a little trickier. So we want to know this area in between these two. Let's see what we can do. Well, we already know that this whole area over here, let me use a different color. This area, goes on infinitely, but this is 16%. So we know it's got to be something less than 16% because we cut it into a little piece. What we really want to know is what is this tail? We can take that out of 16%, and that leaves us with the red area. So this new number they gave us is 2 standard deviations away from the mean, right? And so that's the 95 part of the rule. So that means you got 2.5 in this tail and 2.5 in this tail, because 95% of the data is in this blue area, because that's 2 standard deviations in the mean. And if 95% is here, then 2.5 is here and 2.5 is here. So if that's 2.5, and we know that everything to the right of 33 should be 16%, it's just a quick subtraction problem. There should be 13.5% in between those two. Describe the gas mileage of the best 2.5. I think that's what we just got, right? 38.2 is two standard deviations away from the mean. So 2.5% are better or equal to 38.2 miles per gallon. So that's what we know about the best 2.5% of cars that get either 38.2 or better.